All right, so I'm going to do a little general talk about systems of equations and the types of problems that you have. I think this whole chapter is going to be systems with three variables. And you're going to get the nicer ones where we have. I'm not going to solve this because I'm just making these up and the numbers are going to end up being terrible. So again, if you solve this, you would drive yourself insane with terrible numbers. But when I look at this, I see the z's. It'll be easy to get rid of. I'm going to call these equations 1, 2, and 3. It'll be easy to combine 1 and 2 to get rid of z. It'll be easy to combine 1 and 3 to get rid of z. I will have used all three equations, and I'll end up with two equations with x and y. And that's what I want, because once I have two equations with x and y, let's pretend that we get 2x plus 3y equals 5, and 3x minus 3y equals 0. Then I'm going to add those two equations together because my y's will disappear. You always want to make sure, like we did 1 and 2 and 1 and 3, and we got two equations with x and y. Now we have two equations with x and y. I can add the two equations together. And by combining equations, I get rid of another variable, this time y. The first time we got rid of z for both of those. Now we're getting rid of y. And then we're finally solving one equation for one variable, and we get that. So those are nice. I'm going to try to do another one, another type of equation you're dealing with, and that is these wacky ones where they're only giving us two equations. Do I need to do this? I'm hoping I don't have to. They're going to let us. I'm going to say x equals a. And I'm just making up numbers. Well, I guess I should use the same number there. Now x is we're kind of stuck with x. X equals a. Our values for y and z are going to have a in them. And what I need to do is first get rid of one of the variables. In this case, it's easy to get rid of z. And then I'll get an answer for y in terms of x. But it's really going to be, I'll switch out x for a at some point. So I'll have an answer for y. I've got rid of z. I'll have an answer for y that's going to have, instead of x, a in it. And I guess I'll go ahead and do this one. And then I'm gonna get rid of z first, because that's easy. And then unfortunately I'll have to get rid of y. That's going to be more of a pain in the neck. And both of my answers for y and z are going to have a in it, because I'll replace x with a. And so let's go ahead and do that. And I'm just going to add the two equations. I get 5x plus 8y. The z's go away, equals 15. I want to solve for y. You were doing something to j today which was absolutely not wrong, but I'm going to, before I divide by 8 to get y by itself, I'm going to move this 5x over to the other side, and I'm going to get 8y equals minus 5x plus 15. I'm going to divide by 8, and I'll get y equals negative 5/8. Now I'm going to switch it out, not call it x, I'm going to call it a, plus 15 over 8. That's my answer for y. I'm gonna go ahead and try to take these two equations and get rid of y now. So I'll have z left over, and I will ultimately replace x with a. And then when I get to doing the three ordered pairs, I already know one thing. When I do my ordered pairs, I'm letting x equal a. And I'll go ahead, because I already know what y equals, I'm going to go ahead and say that my second ordered trio, I guess you would say, is that, because that's what y equals, based on what we solved up here. And now, unfortunately, I have to get z by itself, because I've got my x coordinate, I've got my y coordinate, and then I got to get y out of there. And I'm going to do that by multiplying this by 5. I think what I'm going to do this time, just to show you that it doesn't matter, instead of multiplying this by negative 3, which I could do, and then I'd add those two, I'm going to multiply this by 3, and then I'll multiply this by 5, this by 3, I'll have a 15y and a 15y, and I'm going to subtract this from that. Oh, goodness, Jay, I didn't write a minus in there. So, over here, I'm going to multiply this top equation. All right, so now that I see that that's a minus 5, I'm going to multiply by 5 and 3, and then I'll just add the 2. And I get a 10x plus 15y plus 5z equals 40. So I multiplied everything there by 5. I'm going to go to the second equation, this guy here, and multiply by 3. I can see that my y's are going to disappear when I add them. Well, once I write that. And so I multiplied this by 3, and that gives me a negative 3z. And that's equal to 21. Now I'm going to add those two together, and I get a 19x. The y's disappear. Plus 2z equals 61. And then I'm going to subtract 19x from both sides, and I get a 2z equals minus 19. I'm going to go ahead and switch that out and call that a, plus 61. And then that gives me a z equals minus 19a over 2 plus 61 over 2. Now I have solved for z, and I'm going to put that in up here for z, and I get a minus 19a over 2 plus 61 over 2. And at j, I spent no time whatsoever trying to think about how these numbers would work out nicely, but it wasn't all that terrible even doing it that way. wasn't pleasant, but then we have a value for for X, Y, and Z. Then the only other, all right, I'm stopping this one because I think I run out of time.